Hello and welcome everyone. Today in this video we are going to discuss the solution of the specimen paper released by Council for Chemistry for the year 2024, and we will analyze the paper also to get some idea about the important topics, and we will discuss the marking scheme, how the marks for a question is distributed in the question. So let us start. The question paper is mainly divided into four sections A, B, C, D. Section A is mainly objective. Now under section A, question number 1, there will be three part A, B, C. Part A is fill in the blanks. Before going to the answers, first we will discuss how marks are given for fill in the blanks type question. Here you will total get 4 questions, 1, 2, 3, 4. Each question will have 2 blanks. Now while writing the answer, many times we see in the paper that, for example, take question number 1. In the Haber process, iron changes the dash of reaction while molybdenum increases the efficiency of the dash. The answers are given with some extra words in the third bracket. You have to choose the correct answer from there. Now the correct answer, you can see the first blank will be activation energy, the second blank will be catalyst. Now suppose you know the answer for the first blank, that is activation energy, but you don't know for the second one. And in answer, what do you write? 1A, question number 1, you just write activation energy. In spite of being correct, you will not get any marks, because in that case you are not clearing whether you are writing activation energy for the first blank or for the second blank. So in this type of situation, the best advice is, if you are writing activation energy for the first blank, write activation energy, underline it, give a comma, and then in the second blank you just keep it blank, or even if you write a wrong answer, you will get the half marks for the first one, for the first correct one. So the advice is, if you know the answer for the first blank only, write activation energy, underline it, give a comma, and then leave the symbol of a blank. Then it becomes clear that you are writing activation energy for the first blank. So in the same way, if you are writing catalyst for the second blank but you don't know the answer of the first, give the symbol of a blank, comma, and then write catalyst underlined, so that you can get at least half marks for the correct answer that you know. Otherwise you will be awarded 0. Now come to the answers. In Haber process, that is N2 plus 3H2 plus 2NH3, the iron, finely divided iron dust, that acts as a catalyst. Now if you see the role of a catalyst, if you take Arrhenius equation, that is K equals to A into e to the power minus Ea by RT, you know the rate constant K can be increased in two ways. Number one, either you increase the temperature, that is why rate of reaction increases on increasing temperature. Another, you decrease the activation energy, then also K will increase. So that is the role of catalyst. It stabilizes the transition state, thereby decreases the activation energy, and hence the rate of the reaction increases. And in Haber process, molybdenum is used to support this iron so that it can work efficiently. That is why it is known as promoter. So the second blank will be molybdenum increases the efficiency of the catalyst. Now question number 2, the number of ions that will be produced when potassium ferrocyanide dissolves in water. So potassium ferrocyanide, the 4 counter K plus ion will give 4 cations, and the complex ion as a whole 1 anion, FeCN whole 6 4 minus. So total 4 cation plus 1 anion, so the answer will be 5. And inside the square bracket you can see the non-metallic part is the cyanide ion, so they are ligand here. So cyanide Cn minus ion is acting as the ligand. Now question number 3, I always suggest you to read the question properly. Most of the student, as we see, will read this one haloalkane instead of haloalkene and will get confused, because haloalkenes are not common in your syllabus. So haloalkene, that means there will be halogen as well as alkene double bond. We know alkenes are very prone towards addition reaction because of the double bond, electrophilic addition, and because of the halogen it will be prone towards nucleophilic substitution by a number of nucleophiles. So haloalkenes will undergo electrophilic addition reaction because of presence of double bond, and will undergo nucleophilic substitution reaction because of presence of the halogen atom, as halides are good leaving group. Come to question number 4. In case of alcohols, as the carbon chain length increases, the boiling point increases. That is so common because as the chain length is increasing, the molecular weight is increasing, so each and every molecule is becoming heavier, so it will be difficult to vaporize them, so obviously boiling point will increase. And the solubility in water, so if the chain length is increasing, that means the hydrophobic hydrocarbon part is becoming bigger, it is becoming more hydrophobic, so obviously solubility in water will decrease. So the first blank will be increases, second one will be decreases. Now let us come to the part B of question number 1, that is in MCQ. First let us discuss the method of writing answer. So you give the correct question number 1B1. Now for the first one the answer is option D, that is only P and S. So if you give the correct question number, that is 1B1, and then you write only P and S, you are not writing this D, you will get full marks. Or if you are writing only option D but not writing the statement only P and S, then also you will get full marks. But sometimes what we see, the student get confused and he chooses two of the option. Suppose it is a 50-50 situation. You know that either option A or option D will be the answer. So sometimes what they try to do, they write here A and in the statement they are giving the statement of option D. In that type of cases you will get simply 0, no marks will be awarded. So write answer only when you are confirmed. So if it is D, then write D and then the statement. This is the best way of writing. But if you write the correct option number, or if you write only the statement of the correct option, then also you will get full marks. But if you mix it, then you will be awarded 0. So here for the first question from electrochemistry, that a potassium iodide solution containing starch turns blue on the addition of chlorine, which one of the following statements explain this? So this is very simple, that Ki plus Cl2 will give you KCl plus I2. That I2 will combine with the starch to give you the blue color, starch iodide complex, right? So I minus is becoming I2, so that is oxidation, and Cl minus from KCl, sorry, Cl2, it is becoming KCl, so that is the reduction. So that is possible only if the reduction potential of chlorine is greater than iodine. So P is correct, that is the reduction potential of Cl2 is greater than I2. And this blue color is coming because of the complexation between starch and iodine. So the product formed when I2 combines with the starch is blue, that is also correct. So the answer is only P and S. The second one, crystal field splitting energy for high spin D4 octahedral complex. If it is D4 and high spin, that means the configuration is T2G3 Eg1. So 3 T2G electron each will get minus 0.4 delta O, and the one Eg electron will get plus 0.6 delta O. So minus 1.2 plus 0.6 giving you minus 0.6 delta O. So option D is correct. That is the correct answer. Number 3, this is a fact based question. The answer is Cr2SO4 whole 3, option D. This gives the green color. Number 4, which of the following product is formed when benzene diazonium chloride is heated with hydrochloric acid in presence of Q plus chloride? This is the famous Sandmeyer reaction, so answer will be chlorobenzene. And number 5, which of the following aqueous solution has lowest vapor pressure? If the vapor pressure is lowest, that means the lowering in vapor pressure is highest. So we have to see where the colligative property will be highest. That means maximum number of particles, and that will be for K2SO4, because if you assume 100% dissociation, one K2SO4 will give you 3 ions, so the effective concentration of solute particle will be 3 times, that is 3 molar. For NaCl it will be Na plus and Cl minus, so it will be 2 times, Glucose and sucrose being non-electrolyte will not dissociate, so they will remain 1 molar. So we are getting highest effective concentration for 1 molar K2SO4, and hence the correct answer will be B, 1 molar K2SO4. Now let us come to the next part, that is assertion reason. Two such questions will be there. As I mentioned that read the question carefully. See the assertion for question number 6. Adding water to two beakers A and B containing sodium hydroxide and acetic acid solution respectively will increase the molar conductance of the solution sharply in beaker A and slowly in beaker B. So A is NaOH, that is a strong electrolyte, B is acetic acid, that is a weak electrolyte. And on dilution, the molar conductance of weak electrolyte increases sharply, and for strong electrolyte it increases slowly. So here actually the assertion is wrong, because for NaOH they are saying sharply in beaker A, but actually it will be slowly. So here assertion is wrong. So the correct option will be option D, assertion is false, but reason is true, because molar conductance increases with decrease in concentration or dilution. Now come to the next one. Aniline is soluble in HCl while it is only slightly soluble in water. That is correct. You use aniline in your practicals also. You have seen it is not soluble. It gives you a suspension. But on adding HCl, it gets soluble because of protonation. Aniline becomes anilinium ion and gets easily dissolved. So here both assertion and reasons are correct. So option A will be answer C. Here I have a small mistake. Number 7, it will be A. Both assertion and reason are true, and reason is the correct explanation of assertion. That is a printing mistake. It will be A. See, if you write D and then suppose you get confused, you think D can be correct or A can be correct. The option elimination way. You know that B and C cannot be, so between A and D will be the answer, and you write in this way, you will get 0. Either you write question number 7 option A, or you write question number 7 then the statement, or you write option A and then the correct statement corresponding to option A. But if you write in this way, you will get simply 0. So be careful. Now let us come to the next question, that paragraph based question. So you read this paragraph. Mainly the questions are a little bit theoretical. Why CaCl2 is sprinkled? You know that if you sprinkle CaCl to salt, that will cause depression in freezing point, and in the atmospheric temperature, in the cold weather, in the atmospheric temperature, the snow will start melting as its freezing point goes down. A mixture of ethylene glycol and water is used as coolant, because if you add some ethylene glycol in water, that will do two things: depression in freezing point and elevation in boiling point. So the temperature range will become wider in which it can work as a coolant. On the other hand, due to depression in freezing point in cold weather, it will prevent the coolant from freezing. So these are the two main reasons. And number 3, how many grams of ethylene glycol should be added to, that is the numerical problem. In numerical problem, remember, be it 1 mark problem, be it 2 marks problem, be it 3 marks problem, there is always some marks given for writing the correct working formula. It may be half, it may be 1. So whenever you are doing any numerical, first write the symbolic presentation of the working formula. That will give you at least some marks, even if you do the problem wrong. So here the correct formula is, we know delta Tf equals to abelioscopic constant Kb into molality. Molality is 1000 W2 by M2 W1, and just put the correct values. Here you have to calculate W2. So put the correct values and this will be the answer, 3333.33 gram. See, in the question it is clearly mentioned that how many grams, so you don't need to convert it into kg. Let us come to now section B. Section A, 14 marks is complete. Here you will not get any option, any alternate. All the questions are compulsory. Now come to section B. Question number 2. You have to arrange these three compounds in decreasing order of activity towards Lucas reagent. Now decreasing order, whenever you get any question where you have to arrange in decreasing order means the symbol will be greater than the sign, and for increasing order it will be less than. Now suppose the question is arrange in decreasing order and you are using less than sign, but your order is correct, you will get full marks. Similarly, if the question is increasing, the correct answer you should write in the form in the using less than sign. But if you write using greater than sign but your order is correct, then also you will get full marks. But don't use the comma sign, that is up to class 10. Don't use the comma sign here, either use less than or greater than, use it and give the correct order, then you will get full marks. So here you have to write only the order. Since explanation is not required, is not asked in the question, there is no need to write the explanation why you are getting this order. Just write the correct order. Be precise, write to the point. So we know that for isomeric alcohol, as the degree increases, the activity towards Lucas reagent increases. 3-degree alkyl halide will be the most reactive, then 2-degree, then 1-degree. So the order will be 2-methyl-2-propanol greater than 2-butanol greater than 1-butanol. Next question is ethanol has higher boiling point than methoxymethane. In this question, 1 marks question, explanatory 1 marks question, we always search for the keyword, and here the keyword is intermolecular hydrogen bonding. Okay, so in alcohol, because of the highly electronegative oxygen is carrying the hydrogen, it can undergo intermolecular hydrogen bonding, but in ether there is no hydrogen directly attached to oxygen, they are attached to carbon, so intermolecular hydrogen bonding is not possible. Now come to question number 3. Again, give reason. As I said, search for the keyword. The size of the trivalent cations in lanthanoid series decreases steadily as the atomic number increases. So the keyword is lanthanide contraction. Along with it, you can give a little bit of explanation of lanthanide contraction, that is due to the poor shielding or screening effect of F orbital. So that is the main reason. Don't write so many things, paragraph, half page, 1 page, that irritates the examiner who is checking your paper. So go for the keyword, 1 sentence, maximum 2 sentences, and it is sufficient. Now question number 2, the third ionization energy of manganese is unexpectedly high, because third ionization energy means conversion of dication to trication, Mn2 plus to Mn3 plus. So Mn2 plus has 3d5 configuration, so it will be difficult to convert it to Mn3 plus which has d4 configuration, because 3d5 is a half filled subshell which is highly stable. Next come to question number 4. Give balanced chemical equation to convert the following. Remember, when the question has the heading give balanced chemical equation, this balanced word is very important, and this equation word is also very important. Chemical equation, if it is written, you have to give the byproducts. If any one byproduct is missing, you will not get any marks. And along with chemical equation, if the word balanced is also there, then you have to balance the equation also. Now for balanced chemical equation, if you write the correct chemical equation with all the byproduct but the equation is not balanced, you will get half marks. If it is a 1 marks question, you will get half. If it is a 2 marks question, you will get 1. But if you miss any byproduct or any reactant, then no marks will be awarded. Half marks is also given for condition of the reaction. So you have to write the condition also. It may be catalyst, it may be heat, it may be temperature, whatsoever. So first one is benzene to biphenyl. You can do it in two ways. Benzene, first you can convert it into nitrobenzene, then aniline, then diazonium, and after getting diazonium you can treat it with benzene and NaOH, so you can get biphenyl. That is another way, but that is a long process. This one is relatively shorter, only 2 steps. Benzene undergoes aromatic electrophilic substitution when treated with chlorine in presence of some halogen carrier, that is anhydrous FeCl3, in dark condition, because in presence of light chlorine may undergo homolytic cleavage and radical mechanism may start. So in presence of anhydrous FeCl3 dark condition, you will get chlorobenzene, byproduct will be hydrogen chloride. And now this chlorobenzene can undergo Fittig reaction in presence of sodium and dry ether to give you biphenyl. Second one is propene to propan 1-ol. Since it is propan 1-ol, so you need 1 bromopropane, and that can be possible only when the addition is anti-Markovnikov. So HBr, here you have to mention peroxide. So this will be the major product, 1 bromopropane, and then nucleophilic substitution using aqueous KOH, you will get 1 propanol. Next, salts of cuprous ion are colorless, whereas salts of cupric ion are colored. So the keyword here is unpaired electron. Cu plus no unpaired electron because fulfilled 3d10 configuration, and Cu2 plus 1 unpaired electron will be there as it has incompletely filled 3d9 configuration. Next, zinc is not regarded as transition element. Like zinc, in the same group, cadmium, mercury also there, they are also not regarded as transition element, because for this group you will get always fully filled 3d10 configuration for zinc, 4d10 for cadmium, 5d10 for mercury. Even at their stable oxidation state +2, then also it will be d10 configuration, because the 2 electrons will be eliminated from the next s orbital. So they cannot have incompletely filled d subshell, and hence they cannot be regarded as transition element. Next question. Question number 6. Two compounds D2-chlorobutane and L2-chlorobutane are enantiomer. So you have to name one physical property which is same and which is different. So most of the physical properties will be same. Here I have written boiling point, you can write melting point, you can write refractive index, you can write surface tension, you can write viscosity. In most of the physical properties, specific heat, all those things will be same. The only property, since they are enantiomer, they are optical isomer, so their optical property that will be different. So you can write it optical rotation or specific rotation, that is the angle by which it rotates the plane polarized light. One will be dextrorotatory, that will rotate the plane of polarization in clockwise, the other one by the same angle but anti-clockwise, so they will be equal and opposite. If D2-chlorobutane is plus theta angle or theta degree in clockwise fashion, then L2-chlorobutane will be same theta degree but in anti-clock fashion, that will be minus theta degree. Another property, though not in your syllabus but will be different for these two enantiomer, that is also an optical property, that is the reactivity towards optically active reagent. If you take optically inactive reagent, like normally you are doing substitution with aqueous KOH, their reactivity will be same, the rate of the reaction will be same. But if you use any optically active reagent and they are reacting with this two enantiomer, the speed of the reaction will be different for the two enantiomer. Though that is somehow related to chemical properties, not physical property, because that is chemical reactivity or speed of the reaction. So better write optical rotation or specific rotation, or you can write angle of rotation, that will be also correct. All these three will be correct. Now come to question number 7. A rusted piece of iron undergoes electrochemical reaction. Write the chemical reaction taking place at cathode and anode. Now see, you have 3 topics in electrochemistry from where direct descriptive question may come. One is this corrosion, the cathode anode reaction. Number 2 is the lead storage battery. There also you will get cathode anode reaction. One for charging the battery, another for discharging the battery. If you remember, for charging, then in case of discharging, just reverse the cathode reaction and reverse the anode reaction. Product will come to reactant and reactant will go to product. But you have to remember. And the third one is hydrogen oxygen fuel cell, the cathode reaction and anode reaction. And there is high chance that this year in 2024, any one of these 3 topic will be there in your question paper, either cathode anode reaction of corrosion, or cathode anode reaction of H2O2 fuel cell, or cathode anode reaction of lead storage battery, either for charging or during discharging. So this is a fact based question. You can find the answer from your book. I have also given the answer here. You can copy from here. Now next question is, given that the standard reduction potential for aluminum system and iodine system given, what will be the standard potential of the cell made by this? So from the two reduction potential, you can see it is greater for iodine, because when we compare reduction potential, we have to consider the sign also. So plus 0.54 obviously greater than minus 1.66. So the one having higher reduction potential will be reduced, and reduction takes place at cathode. So here iodine will be the cathode, aluminum will be the anode, and we know E naught cell is E naught cathode minus E naught anode. So simply the answer you will get is 2.20, E naught iodine system minus E naught aluminum system. Now come to the next one. What happens when, and see in the bracket it is written write chemical reactions only. Since they have asked for the chemical reaction, so here again they are asking for the equation. Now in this question the word balanced is not there. So if your skeletal equation is correct, skeletal equation means all the reactant and products are there including the byproducts, but balancing is not there. So if that part is correct you will get full marks. Here balancing is not needed, if you want you can give, but all the reactants, products, byproducts must be mentioned. So the first one is diethyl ether is treated with phosphorus pentachloride, that gives 2 chloroethane, 2 molecules of chloroethane or ethyl chloride, and the byproduct is POCl3. And ethanol treated with Grignard. Now this one is very interesting. In class 11 you have learned in the preparation of alkane that Grignard reagent on reaction with water give alkane. If it is RMgX, then reaction with water it will give RH. It is not only water, actually Grignard reagent, if it comes in contact with any potential H plus donor, it may be water, it may be alcohol, it may be carboxylic acid, it may be ammonia, it may be some terminal alkyne having acidic hydrogen or acetylenic hydrogen. It can be some compound with active methylene group. Active methylene group means CH2, and the two side there will be C double bond O, so that if H plus is removed the minus charge gets resonance stabilized. So any compound which can give H plus, which has a little bit of acidic hydrogen, if Grignard reagent comes in contact with that, it will be converted into alkane. So the same thing happens with alcohol. So alcohol, this OH, this hydrogen will be taken by the R group of the Grignard, that is CH3 here, to give you CH4. And magnesium, it is bonded to bromine. The CH3 part goes with the hydrogen, becomes CH4. So the remaining part, the ethoxide ion OCH2CH3 will come with magnesium. So the byproduct will be magnesium, one bond to bromine, the other bond is OCH2CH3. Now here you will get an alternate, the alternate will be internal from the same chapter. So that is the root map question. An organic compound A having molecular formula C6H6O gives a characteristic color with aqueous FeCl3 solution. Now this is a trial and error method. I always suggest that whenever you see this type of problem and the molecular formula is given, if the number of carbon is 6 or greater than 6, just assume there is phenyl group. In 95% cases you will see molecular formula having 6 carbon or more than 6, they are some benzene compound with some substituent, maybe phenol, maybe aniline, maybe cyanobenzene, maybe benzaldehyde, etc. And see, characteristic color with FeCl3 solution, that can be the case of either phenol or aniline. In practical you have done that aniline with neutral FeCl3 followed by some HCl give pale green coloration. Here the color is not mentioned, but there is no scope of being aniline as no nitrogen is there. So speculation says that this can be phenol, and this is matching with the formula of phenol C6H5OH. So now assuming this one phenol, you move forward. A on treatment with CO2 and NaOH at 400 Kelvin under pressure gives boron, which on acidification gives compound C. So this looks quite coal-based reaction. In some of the books it is written coal-based meat, that gives actually salicylic acid. Initially it gives sodium salicylate because the medium is NaOH, so the acid will remain as a sodium salt. On acidification the COONA will become COOH, so it gives you salicylic acid. And then C reacts with acetyl chloride to give D, that is the acetylation reaction. OH will become OCOCH3, and this is the famous painkiller aspirin. We had one chapter chemistry in everyday life, but in the reduced syllabus it is not there. If it was there you could have find it, that aspirin, paracetamol, all these compounds are there. This is aspirin. So this will be the answer A, B, C, D. Okay. Now here you can write the names of the compounds also, because it is given identify the compound. So if you write A equals to phenol in word, PHENOL, B is sodium salicylate, C is salicylic acid, D is aspirin, then also you will get full marks. But if the question says write the structures of ABCD, then you have to show the structure. But remember, if you write A is C6H6O, that is the molecular formula, you will not get marks. If you write C6H5OH, then also you will get marks. But I always advise, always draw the structure. Now, question number 9, that is again a numerical problem. As I mentioned earlier in the previous slide, that first write the symbolic presentation of the correct working formula. Delta TB is Van't Hoff factor I into ebullioscopic constant Kb into molality, which is 1000 W2 by M2W1. For writing this, you will get marks. And be careful about the unit of the final answer. Okay. Then do the substitution properly. Check the answer in your calculator 2 times, 3 times, because if your final answer have an error more than 1%, marks will be deducted. So always go for at least 3 decimal place for calculation in every step, at least 3 decimal. So just put this substitute the formula with correct values, you will get delta TB. They are asking for the boiling point, so boiling point of solution is elevation in boiling point plus boiling point of pure solvent, that is water here, which is 373 Kelvin. So this will be the final answer. Next question, number 10. Aromatic aldehydes do not give a reddish brown precipitate on heating with failing solution. See, failing solution, if you see the equation, the reaction with failing, Cu2 plus is converted to Cu2O, Q plus oxide. So basically Cu2 plus is getting reduced to Cu plus, and the reduction potential for this system is around nearly 0.15 volt. If you see Tollens reagent, then the reduction potential Ag plus is precipitated as metallic silver, so this reduction potential is 0.80. So one thing is clear, that Tollens reagent is a very strong reducing agent compared to failing. Now aromatic aldehydes, they are difficult to oxidize because of the partial double bond character between the aldehydic carbon and the benzene carbon. So Tollens reagent, being a strong oxidizing agent, can oxidize the aromatic aldehyde and itself get reduced to give you the silver mirror. But failing solution, that is being a relatively weak oxidizing agent, cannot oxidize the aromatic aldehyde, so you don't get the red precipitate. Second question is, why is benzaldehyde less reactive towards electrophilic substitution? I already mentioned that due to resonance, there is a partial double bond character between the aldehydic carbon and the benzene carbon. Why? Because the aldehyde group exerts electron withdrawing minus R effect. Since this resonance effect is electron withdrawing in nature, that means it is reducing the electron density of the benzene ring. So it will be difficult for the electrophile to come close to the benzene and substitute the hydrogen. So being an electron withdrawing group with very strong minus R effect, aldehyde deactivates the benzene ring and make it less reactive towards electrophilic substitution. Now again, give reason type question. So keyword, we will search for the keyword. Transition metal act as good catalyst. Here the keyword is variable oxidation state or variable valency. If you write a lot of things, there is a vacant d orbital, unpaired electron, etc., etc., you may get marks, you may not get marks, because each year the marking scheme by the council varies. But if you write the correct keyword, then every year you will get full marks. So here the keyword is variable oxidation state. Now why it shows variable oxidation state? Because it can involve both the outermost s electron and the penultimate d electrons to show its variable valency. Next question is, scandium does not exhibit variable oxidation state, yet regarded as transition element. If you see the definition of transition element, earlier I have said for the case of zinc that it is not a transition element. The condition to become a transition element is incompletely filled d subshell, and it is there for scandium as it has 3d1, one electron in the 3d subshell. So that is incompletely filled d subshell, not d10, not d0. So scandium is also considered as transition element. Next, number 12. This type of problem, kinetics, you table problem where some data are given. So you always see at least two data where the concentration of one of the reactant remains same but the other one changes, and that is true here for experiment 1 and 2. See, concentration of B remains constant but A becomes double, and you see the rate also, the rate becomes 4 times on going from observation 1 to 2. So you simply take the order with respect to A and B as alpha and beta. So the rate equation will be R equals to some K into A to the power alpha into B to the power beta. Now apply this equation for all these three observations. As in 1 and 2 the concentration of one of the component is same, so we will divide equation 2 by equation 1, so that this part gets cancelled, doesn't matter whatever is the value of beta. 0.30 to the power beta by 0.30 to the power beta will give you 1. K and K will also cancel, so 0.30 by 0.15, that is 2, so 2 to the power alpha will remain on the right side, and the left side it is 4. You get easily the value of alpha. Similarly, if I do 3 by 1, then none of the terms are getting cancelled. It will be 4 to the power alpha, 0.60 by 0.15 is 4, so 4 to the power alpha, and 0.15 by 0.30 is half, so it will be half to the power beta. Now in the previous line we got the value of alpha, so we can put the value of alpha here, and rest of the calculation will give you beta equals to 1. So simply put the values of alpha and beta in the rate equation, it becomes K into A square into B. Coming to the next one, arrange in increasing order of basicity, one in aqueous phase, one in gaseous phase. This is one of the most important question from amines chapter. Methylamines and ethylamines, 1 degree, 2 degree, 3 degree, their order of basic strength in gas phase and in aqueous phase. In gas phase it is always 3 degree greater than 2 degree greater than 1 degree, because only inductive effect is the governing factor. But in case of aqueous phase, as you know, both the stability of the conjugate acid and the inductive effect plays role, but in opposite direction. So you have to memorize, you have to remember, you have to learn the experimentally obtained order in aqueous phase. For ethylamine the order is 2 degree greater than 3 degree greater than 1 degree, and for methylamine it is 2 degree greater than 1 degree greater than 3 degree, and in gas phase it is always 3 degree greater than 2 degree greater than 1 degree. So in that way you get the answer. Now come to question number 14. What products are obtained when sucrose is subjected to acid hydrolysis? You have total 3 disaccharides in your syllabus, that is sucrose, lactose and maltose. Sucrose, so in your main paper 2024 ISC, instead of sucrose they may give lactose or maltose. So sucrose give D-glucose and D-fructose. Don't forget to write capital D. The best answer will be alpha D-glucopyranose and beta D-fructofuranose, but at least you write D-glucose and D-fructose. Similarly for lactose it will be D-glucose and D-galactose. For maltose it will be 2 molecules of D-glucose. Okay. Why are vitamin B and vitamin C essential for us? This is a totally informative question, fact based question. You can find the answer in any book. Just write, I have given so many functions here. You write at least one proper function of vitamin B and one proper function of vitamin C. Other than this, the chemical name of vitamins and the most important, deficiency syndrome. These are very important. One more important question from vitamin is their solubility, fat soluble vitamin and water soluble vitamin. So these are the 4 types of question: function, chemical name, solubility and deficiency syndrome. Rickets, scurvy, beriberi, all those diseases are there. So these are fact based question. Next, on being heated, egg white becomes solid and opaque. Give a reason. This is simply denaturation of protein. If you write only this is due to denaturation of protein present in egg, you will get full marks. Those students who are taking biology, they know that the protein present in egg is albumin protein. So if you write this is due to the denaturation of albumin protein of egg, the answer becomes a little better, but in both the cases you will get full marks. Next question. Question number 15 in the specimen paper. This question is actually related to the chapter equilibrium from class 11. We will apply Le Chatelier's principle here. Because if you take the equilibrium of liquid water and water vapor, then what will be the equilibrium constant? It will be pressure of water vapor by concentration of liquid water, and liquid water being a pure liquid, it will be considered as 1. So simply what is happening, the vapor pressure of the water vapor is simply the equilibrium constant here, and we know equilibrium constant cannot be changed unless and until temperature is changed. So you can see in both the questions it is given that temperature is constant without any change in temperature. So if temperature is not changed, equilibrium constant will not change, and here vapor pressure itself is the equilibrium constant, so vapor pressure will also not change. The equilibrium will shift either to left or right according to Le-Chatelier's principle. It will rearrange itself so that the equilibrium constant remains same, and in this case equilibrium constant being the vapor pressure itself, so the vapor pressure will also remains constant. So you just have to give this logic and then write the same answer for both 1 and 2. This is not a good question, but since the question is given, if you have to write the answer, you have to write in this way. Give the correct logic and then write that the vapor pressure will remain constant, it will not change. Now question number 16, identification. This type of question often comes in your exam. So first one, benzoic acid PCl5, that will give you benzoyl chloride C6H5COCl. Then this is your Rosenman reduction, you will get benzaldehyde. Benzaldehyde in presence of alcoholic KCN will undergo benzoane condensation to give you benzoin. In the next one, this is the hydration of alkyne. Acetylene gives you acetaldehyde and higher alkyne gives you ketone. So here acetylene, so first it will give you the enol which tautomerizes to give you acetaldehyde. Dichromate H2SO4 is oxidation, so you will get acetic acid. Calcium hydroxide will first react with acetic acid, that is acid base reaction to give salt and water. So the salt obtained will be calcium acetate. That calcium acetate is undergoing dry distillation, so calcium carbonate will be removed and the product obtained will be acetone. That is pyrolysis of calcium salt of carboxylic acid. Next, question number 17, conversion, and see here, give chemical equation so you cannot miss any byproduct. But since the word balanced is not given here, you don't need to balance the equation. Now first one, picric acid from phenol. Picric acid is 2,4,6 trinitrophenol. You can do it in one step also. Phenol directly treated with a mixture of concentrated H2SO4 and concentrated HNO3. But if you see your book, you will find that in that case the yield of the picric acid, that becomes very poor, the yield. So the better method is first to do sulfonation using concentrated H2SO4 to get a mixture of ortho and para hydroxy benzene sulfonic acid. Now the sulfonated product, if treated with concentrated HNO3, the byproducts will be water and H2SO4 here. In the previous case only water. In this case now you will get a very good yield of picric acid. So this will be a better answer than direct nitration with mixed acid. Ethyl acetate from ethanol, that is simply esterification reaction. Uh, Due to some technical error, I could not give the correct reversible sign here. You will give the correct reversible sign, and you know that concentrated H2SO4 is used as a catalyst here, that give you simply ester and water. This is a reversible process. Okay, give proper reversible sign here. Third one is anisole from sodium phenoxide, that is simply your Williamson synthesis. So phenoxide plus methyl bromide will give you anisole and sodium bromide. Now the OR question is, explain the mechanism of acid catalyzed dehydration of ethanol to yield the corresponding alkene. You have only few mechanisms in your syllabus. This is one of them, dehydration of alcohol. You have mechanism of esterification reaction, that is also important. You have mechanism of aldol condensation reaction, and you have mechanism of Cannizzaro reaction. So these four mechanisms are very important, since in the specimen paper we can see one mechanism is given. So one mechanism related question out of these four may be there in the final paper. So the mechanism is very simple. The acid catalyst actually convert this OH into OH2 plus, which is a good leaving group, so that dehydration can take place easily. So in the first step, the alcohol will get protonated using the lone pair of oxygen. Will take this H plus to give you protonated alcohol. Now you have a very good leaving group water. it departs, leaving behind a carbocation. Now the departed water, it acts as a Lewis base, take this beta hydrogen which is acidic to give you the final elimination product, that is ethylene, the alkene. Here the formation of the carbocation is the rate determining step. You can explain the mechanism further, I will show it in the next slide, but if you write this much, that will be sufficient. Here I have explained the mechanism, whatever I said in the last slide. Now next question, again numerical problems, very simple. Just I advise that always write the symbolic presentation of formula first, so that you don't lose the full marks if you are wrong. So this is the equation for first order reaction, the integrated rate law. Just substitute properly. They are saying that radioactive decay being a first order reaction, they are saying 80% remaining, so the denominator will be 80 if you take numerator 100. And for first order reaction, we know rate constant is 0.693 by T half, and this gives you the answer. The next question is related to Arrhenius equation. See here again I have written the symbolic presentation of Arrhenius equation that we get from Arrhenius equation. Actual Arrhenius equation is K equals to A into e to the power minus A by RT. From there, if we put the rate constant K1 and K2 for two different temperature T1 and T2 and take log both sides, we arrive to this equation, and then substitute correctly, you will get your final answer. Now here be careful about the unit also. In hurry, sometimes you write the energy of activation energy joule only or kilojoule. Remember, activation energy is an intensive property and it is always per mole, be it joule per mole, be it kilojoule per mole. One more point where you do the mistake is putting the value of R. Be careful where to put R equals to 0.0821, where to put R equals to 8.314. Here we are calculating energy, so we need the final value in joule, so we will put R equals to 8.314. But when in an equation there is atmosphere unit for any quantity, there you will put R equals to 0.0821. Now come to section D. You will have total 3 questions here, each 5 marks. Again, explanatory question, formaldehyde does not undergo aldol condensation but acetaldehyde does. This is simply the case of alpha hydrogen, because you know without alpha hydrogen aldol condensation is not possible. Chloroacetic acid is stronger than acetic acid. It is simply the electron withdrawing minus I effect of chlorine which helps to dissociate the OH bond, and hence chloroacetic acid is stronger. Both aldehyde and ketones undergo a number of nucleophilic addition reaction, because oxygen being highly electronegative, a partial positive charge develops on the carbonyl carbon, and that actually invites the nucleophile, so it can undergo a number of nucleophilic addition reaction. Again, a root based question, C7H6O, the number of carbon is more than 6. So assume there is C6H5. So if I subtract C6H5 from this formula, what is remaining? CHO, that is aldehyde group. So we can assume this is benzaldehyde. Now check whether benzaldehyde is matching or not. Oxidized by tolerance reagent being an aldehyde, obviously does not respond to Fehling test. Just now we have discussed why aromatic aldehydes does not respond to Fehling test. Undergo Cannizzaro reaction, yes, benzaldehyde has no alpha hydrogen, so obviously it will undergo Cannizzaro reaction. So we will actually write these observations to find the molecule C7H6O. Since response to tolerance test, so it will be aldehyde. No response to Fehling test, it will be aromatic aldehyde. Undergoes Cannizzaro reaction, no alpha hydrogen. Formula given C7H6O. So the only possible structure can be benzaldehyde, which is C6H5CHO. So writing these 3 logical conclusion, 3 into half, and finally identifying benzaldehyde another half. So this is the 2 marks question, and under question 1 ABC each 1 mark. So that is the 5 marks. It is how distributed. Question number 20. When 1 mole of an isomer of the complex, it produces 1 mole of a white precipitate of AgCl. 1 mole precipitate of AgCl, that means you have only 1 mole of ionizable chlorine. That means outside the square bracket as counter ion you will get only 1 chlorine. So out of this 3 chlorine, 2 chlorine will go inside the square bracket for the isomer. So if 2 chlorine has to go inside, then 2 water has to come outside. Water cannot be counter ion, so it will be water of crystallization dot 2H2O. So the formula is CrH2O whole 4 Cl2, outside only 1 chlorine 2H2O. This chlorine, the counter ion which is not a ligand, this will dissociate to give you Cl minus, which will combine with Ag plus to give you 1 mole AgCl. But the two ligand chlorine inside square bracket are non-ionizable, so that will not give you precipitate. That is what written also in the explanation. Next, this question, 20 part 2, this is a little bit controversial, because seeing the hybridization D2sp3, you cannot certainly say always whether the ligand is strong ligand or weak ligand. That is why I have written this answer in this way. If the number of electron present in the D subshell is either 1 or 2 or 3, be it weak ligand, be it strong ligand, the electrons will be in the T2G level, Eg will be vacant. So it will be T2GN Eg0, and in that case it will be always D2sp3 hybridization. So if the metal ion contains only 1 electron or 2 or 3 in the D subshell, it is not possible to certainly say whether the ligand is weak or strong. But if the number of electrons are 4 or 5 or 6, then only in presence of a strong ligand Eg will be vacant. The electron from Eg will come down to T2G for pairing due to crystal field stabilization. So in that case we can definitely say that the ligand is a strong one if the hybridization is D2sp3. And above D6, that is D7, D8, D9, D10, the hybridization will be always sp3d2. So leave that part. So for D2sp3 hybridization, if the metal ion contains 4 electrons or 5 electrons or 6 electrons in the D subshell, then it is certain that the ligands present are strong ligand. But in case of D1, D2, D3, D3 for example, a chromium 3 plus complex, we cannot say anything whether the ligand is strong or weak. So you have to write the answer in this way for this type of controversial questions. Now, question number 21, the last question. Here you have an internal alternate. This is the question from electrochemistry. This picture is given, but whatever information is given in the question, the picture is not needed actually. So calculate the value of E naught cell and del G naught. They are not asking for E cell, so Nernst equation will not be required here. They are asking for E naught cell, the standard one. The reduction potentials are given. It is clearly written which one is anode, which one is cathode. So simply we know that E naught cell is E naught cathode minus E naught anode. So Sn2 plus Sn minus Zn2 plus Zn. Now here very often we see a mistake. Students forget to use the minus sign two times. One minus for the equation, the other minus because the value given is minus 0.76. So it will become minus minus plus, and the value will come positive. And then del G naught, it is minus NF E cell, NF E naught cell. N will be 2 electrons here because both cathode and anode are 2 electron process here. In many cell you will find that the number of electrons in cathode and the number of electrons in anode are different. In that case N will be the LCM of those two number of electrons. Suppose left side it is 2 electron process, right side 3 electron. LCM of 2 and 3 is 6. So in that case N will be 6. So the answer here, it is obtained in joule unit. You can convert it into kilojoule or you can keep it here. Next question is not a very easy one, because here you need the concept from class 11, first chapter, basic concept, concentration, all those things. First of all, they are saying MnO4 minus to Mn2 plus. So that is a redox reaction. Not redox, that is a reduction reaction, half cell reaction. You need to know this equation, MnO4 minus plus 8H plus 5 electron giving you Mn2 plus and 4H2O. This one is used in your titration that you do in practical chemistry, one with more salt, another with oxalic acid. In both the cases, MnO4 minus is converted to Mn2 plus, and this is the half cell reaction. So the reaction clearly says 1 mole MnO4 minus needs 5 moles of electron, and 1 mole electron is 1 Faraday, so 5 mole electron is 5 Faraday. So for 1 mole MnO4 minus you need 5 Faraday. Now the concentration is given 0.5 molar, volume 500 ml. So first you calculate number of moles and it is coming 0.25 mole. Now unitary method, 1 mole require 5 mole electron, so 0.25 moles. How many moles will be required? 5 into 0.25. So you will require 1.25 Faraday of electricity. Now in the question it is clearly written electricity in Faraday. So I advise you stop here, 1.25 Faraday. Even if you are over enthusiastic and if you want to convert it into Coulomb, do it in bracket. But highlight this one, 1.25 Faraday, as your answer. Now come to the alternate question and the last question here. This one is very interesting. If you see the Debye-Hückel limiting law, you will see that is applicable for strong electrolytes only. So linear graph for lambda m versus root c can be obtained for strong electrolyte only, but it becomes a non-linear curve when it is a weak electrolyte. And the out of these three given electrolytes, ammonium hydroxide is weak. So one thing is clear, that graph 3 will correspond to NH4OH. Now another thing, among many strong electrolytes, when you take any hydroxide base or protonic acid which can give OH minus or H plus, they show abnormally high conductance, molar conductance, because of H plus and OH minus. In higher classes you will come to know that H plus and OH minus can move very fast in the solution using a mechanism known as Groth's mechanism. So strong electrolyte which can produce H plus or OH minus show abnormally high conductance. Even in the second problem you can see the given value, lambda naught of H plus 349.6, lambda naught of OH minus is around 200, whereas you see format ion it is only 54.6. If you take it for Na plus, K plus, they are around 70, 74, 80 like that, but H plus 349, OH minus 200. So here we have H2SO4 and Na2SO4. H2SO4 will give you H plus. So obviously for a fixed concentration, H2SO4, its molar conductance will be much higher than Na2SO4. So if you fix at a particular concentration, for graph 2 the molar conductance is less, the height is less. For graph 1 the molar conductance is high. So obviously 1 will correspond to H2SO4, 2 will correspond to Na2SO4. And the last numerical problem, they are asking for degree of dissociation. Lambda m is given, and instead of giving lambda m naught, they are giving individually for the ions. So use Kohlraasch law. Lambda m naught of formic acid, it will be simply for H plus and HCO minus, you get the lambda m naught of formic acid. Now degree of dissociation is, for a particular concentration, is the lambda m at that concentration by lambda m naught. Sometimes they give one extended part with this problem, that find the dissociation constant of formic acid. So that again goes to class 11 ionic equilibrium, C alpha square by 1 minus alpha. So C is given, I think, concentration, okay, it is given dilute solution. If they ask for the dissociation constant, instead of writing dilute solution, they will give the concentration. So that will be C. Alpha is obtained 0.0843. So the formula will be C into alpha square whole divided by 1 minus alpha, and you will get the dissociation constant. Remember, dissociation constant being an equilibrium constant will be unitless. So that's all about your specimen paper. Question will be of similar type. Strictly follow the reduced syllabus released by council for your board exam, and the points I have mentioned, follow them for balanced equation, byproducts, correct working formula, careful about the unit, how to write the answer for fill in the blanks, how to write the answer for MCQ, okay, write to the point, go for the keywords. All these points if you maintain and if you write in a legible handwriting, I wish you all the best, that whoever is seeing this video, listening to me, you all score above 90%, above 95%. So all the best to you. I will try in this limited time before your exam, if I can come with more sample paper, some more questions to discuss with you. Thank you. All the best for your exam.